All right, ladies and gentlemen, we're back and ready to rock and roll. For this video, we are going to be defining the three parallel lines theorem and using it in some mathematical application. The three parallel lines theorem says that, hey, if you've got three parallel lines and they intersect two transversals, they do it in such a way that those transversals are cut proportionally to one another. All right, so I get it. You know, a lot of times we go over these theorems and you're like, oh goodness, what does that didn't even mean make sense to me? Well, let's break it down. Of course, in this example, R, S, and T are our parallel lines. L and M are considered our two transversals to one another. So R, S, and T are parallel. Well, what does this really mean in terms of dividing the proportion, dividing the transversals proportionally? Well, it means it does it in such a way that this top chunk is to this top chunk, just as this bottom chunk is to this bottom chunk. Like I did for the last video, I want to kind of put some color schemes into the mix. It means that UW, if it will do for me, it means that UW is to WY just as VX is to XZ. So matching on up those color schemes right there. But what's also kind of interesting is that you can also kind of add some of these segments together. You see a bunch of segments being added up that would work as well too. And let's kind of look at an application and see maybe where that comes into play. So it says in the diagram, angle 1, 2, and 3 are all congruent. GF is equal to 120, DE is 150, and CD is 300. Find the distance of HF that is between Main Street and South Main. So we see here that we've got some things already put together. But I really want to focus here, guys, on angles 1, 2, and 3. Why is this important to know that angle 1, 2, and 3 are congruent to each other? Oh boy, I hope you realize, because the fact that they are congruent, those are corresponding angles, folks. And if the corresponding angles are congruent, then the lines are parallel to each other. That's our converse of our corresponding angles theorem. So now I have put myself in a position to use the three parallel lines theorem, the fact that I know that they are parallel to one another. All right, so what did the three parallel lines theorem tell us? Well, it told us that the three parallel lines get cut by two transversals. So ED is to DC, just as, I'm trying to change colors here, just as FG is to GH. So I'm just going to match up those colors. So 150 is to 300, just as 120 is to X. We're going to put BHX right here. And of course, this is a super basic concept. We know that 150 is half 300, so we know it's going to end up being 360. But that's okay. We'll continue to go through, or 240. I'm sorry, not 360. 240. So let's just continue on and just act like we didn't know that. We'll cross multiply. We get 150x equals 120 times 300 gives us 30,000. And then we will divide by 150, and we do get 240, right? So that is 240. All right, so there's 240. And you'll kind of see where I made my mistake earlier by saying it was 360, because it wants the distance from HF, all right, between Main Street and South Main Street. Well, that's the combination of 120 and 240. So really the answer to the question, HF, is 360 yards. So let's recap one more time. So what did we do? All right, we went ahead and realized that since all three of these angles were congruent and they are corresponding angles, these three lines are parallel. Once these three lines are parallel, we use our three parallel lines theorem to set up that this piece ED is to DC just as FG is to GH. Set up the proportion as so to find this missing value of X. But it wanted the whole thing HF, so I added them up together, and that's where we got our 360 yards.